Okay, then let's start the video. It's about continuation of the previous video, that is solving questions from moving charges and magnetism. Okay, then let's start the stream. The next example or the next question. The question is, there is a square current carrying loop ABCD of side 2 meter and current I equals 1 by 2 ampere. Then the magnetic moment M of the loop is. They're asking to find the magnetic moment, and this is not as simple as we see here, because this is the axis here, and there is a loop like this, a loop like this. This is a square. The current is going like this, and the angle is 30-degree here. This is x-axis and this is z-axis. This is y-axis. B, C, D, and A is the origin. Now there is a vector involved. Solution magnetic moment is equals to N I into A vector. For finding A vector, will have to multiply the sides. So the magnitude of the sides is 2 meter, but the direction is different. So let's find side DA or AD first. That is this side, DA, this side, which is equals to 2 is the magnitude, cos 30-degree. This is minus I cap, and it's also in the K direction. So minus 2 sine 30-degree, K cap, which will get magnitude, which will get finally to be around minus root 3 I cap minus K cap, and if you want to find next AB or CD, let's take AB here, this one, this segment, AB, which is equals to, it's only in the Y direction, so it is 2 J cap, and to find area we will multiply both of them, M, which is equals to current times dA cross AB, that is area vector here, N, which is equals to 1, which we will get it as m, which is equals to half, which is current, minus root 3I minus k cap cross 2j cap. When we multiply it, we will get m, which is equals to I minus root 3 this is I cap here, I minus root 3 k cap ampere per meter square. Not ampere per meter square, ampere meter square is the unit of magnetic moment. Let's go to the next example. If two charged particles each of charge q and mass m are connected to a rigid massless rod and is rotated about an axis passing to its center and perpendicular to length, then find the ratio of magnetic moment to the angular momentum. They're saying that if two charged particles, they have charge q and mass m, they're connected to a rigid massless rod, and this rod is rotated about an axis passing through the center. It's rotated about an axis passing through the center and perpendicular to length. I think a rod is like this. This is the rotation of axis, I believe. There is charge q and q here. And perpendicular to length, so it is perpendicular to length here. A ratio of magnetic moment and the angular momentum. Solution: magnetic moment, which is equals to NIA, and I we can write it as q by t, which we can also write it as q by 2 pi omega, the frequency, angular velocity, and Substituting in this equation, magnetic moment equals q omega and when we assume the rod is spinning, it is forming a circle. So the radius of this circle will be equal to half of the length, L by 2. And considering since two charges are spinning, let's consider it as two different coils. So this will become 2 q omega by 2 pi, and area, which is pi r square. So you can write it as pi L by 2 whole square. This is r, so L by 2 whole square. Pi cancel, will get magnetic moment, which is equals to 2 also cancel, q omega L square by 4. This is the final magnetic moment. There's a ratio of magnetic moment to angular momentum. Angular momentum, which is equals to 2mr square omega, which we can write it as 2 times of mass by L square by 4. This is the radius here. R square will become L square and omega. And finally dividing these two, we'll get our required answer, which we'll find m by L, which is equals to q omega L square by 4 by 2ml square omega by 4. 4 cancel, omega cancel, L square cancel. We'll get finally the final answer is m by L, which is equals to q by 2m. The key part to this question, which is basically the first key part, is assuming as the number of loops, which is equals to 2. The second part is this relation, or basically omega, which is equals to theta by or 2 pi by t, this relation, and considering the loop, which is pi r square area. Basically the main relation is considering this as 2 and writing it like that, and knowing the formula of angular momentum. Let's go to the next question. The next question is something similar to what I solved in the previous video. There is a spiral. Find magnetic moment of a spiral of uniform wire of n turns carrying current I, having an inner and outer radius of A and B respectively. This is a spiral here. They're saying this radius is A, whereas this radius is B. Now they're asking what is magnetic momentum due to this coil if there is this current I passing through it. Now let's take thickness of the coil to be dr. dr. If we consider thickness of coil to be dr, then total number of turns of coil is dn, which is equals to n by total number of turns b minus a dr, the inner minus outer radius, times the thickness. This is the total number of turns due to this coil, in this coil basically. And magnetic moment, which is equals to nia. It's not capital N, it is small n ia. This n, which is equals to total number of turns per unit length. That is why we took this here. We will get magnetic moment, which is equals to integration of dn I a, which we will get it as ndr by b minus a I and pi r square, which everything except r square we can take outside. Magnetic moment, which is equals to ndr, I mean ni pi by b minus a. We will get r square with respect to dr. The integration is from a to b. This is the inner radius and outer radius. We will get magnetic moment, which is equals to ni pi by b minus a. Integrating r square, we will get r cube by 3. Limits from a to b, so it will be m, which is equals to ni pi 3b minus a times b cube minus a cube. This is the answer. We can further simplify it by cancelling this and writing it as a square plus ab plus b square, but I will not be doing it. Now let's go to the next question. Consider a non-conducting plate of radius a and mass m, having uniformly distributed charge q, rotated about its axis with angular speed omega, we should find the ratio between magnetic moment and angular moment. I have solved a similar kind of question in my previous video. Magnetic moment dm, which is equals to I times dA or NIDA here, where we can write current which is equals to Q by T, where Q equals I times T, and T we can write it as I 2 pi by omega, and since we need I, we can write I which is equals to Q omega by 2 pi, and charge we can write as charge density, or we know charge by pi a square or r square, which is equals to surface charge density. So charge which is equals to and substituting in the equation I which is equals to sigma pi a square times omega by 2 pi. I which is equals to sigma a square omega by 2, and substituting it in magnetic moment equation which is equals to I into a sigma a square omega by 2 times pi a square, and finally dm which is equals to integrating this, we will get magnetic moment which is equals to pi omega pi sigma omega 0 to a r cube dr, we will get magnetic moment to be equal to q omega a square, I mean a cube by omega a cube a power 4 by 4 integration and from before equation we know that pi omega a square is equals to charge, I mean not pi omega, it is pi sigma a square, which is equals to charge. So we will have m, which is equals to q omega a square by 4. The angular momentum of disk about its axis is equals to L, which is equals to m a square by 2 omega. Then if we take ratio of m by L, we will get it as q omega a square by 4 by omega m a square by 2, which we will get it to be 2 ones are 2 twos are, omega omega cancel, a square cancel, q by 2m. Similar to our previous question, we got ratio of magnetic moment and angular momentum should be equal to q by 2m. Going to the next question. Okay, the next question is a magnetic needle is arranged at the center of a current carrying coil having 50 turns with radius 20 centimeter of coil arranged along magnetic meridian when a current of 0.5 milliampere is allowed to pass through the coil. The deflection observed to be 30 degrees. Find horizontal component of Earth's field. Earth's magnetic field. Okay, they're saying a magnetic needle is arranged at the center of a current carrying coil. A magnetic needle arranged at the center of a current carrying coil having 50 turns with radius 20 centimeter arranged along a magnetic meridian. When a current of 0.5 milliampere is allowed to pass through the coil, the deflection observed is 30 degrees. And when there is a 30 degrees deflection, how much of that deflection is due to the Earth's component and how much is the Earth's component? That is what they're asking here. We have to find the magnitude of the Earth's field horizontal component. Solution: the magnetic field due to Earth B, which is equals to BH tan theta, and this is the Earth's component. This is the total magnetic field. We know the total magnetic field, which is equals to at the center, which is equals to mu naught I by 2r, mu naught Ni by 2r. This is the magnetic field due to the coil. Now, if you want to find the Earth's magnetic field, we will get it as BH, which is equals to mu naught from this equation, mu naught Ni by 2r tan theta. This is the equation to find the Earth's horizontal magnetic field component. Not sure what's going on. There seems to be a glitch in here. Anyways, and BH, which is equals to mu naught value is 4 pi into 10 power minus 7 into N value is, I believe, 50 turns into 0.5 milliampere current by 2 times of 20 centimeter, 20 into 10 power minus 2 into tan 30 degrees, which is 1 by root 2. So we'll have root 2 here. 0, 0 cancel. Ones are, twos are, ones are. So BH is equals to pi into 10 power minus 7 into 5 into 0.5 into 10 power minus 3 into root 3. First, let's take the normals one side and 10 powers one side. Pi into 5 into 0.5 into root 3 into 10 power minus 10 into 10 power 2. This 10 power minus 2 will come up, so it will be 3.14 into 2.5 into root 3, which is approximately 1.7 into 10 power minus 8, which is approximately equal to 13.6 into 10 power minus 8 or 136 nanotesla or 0.136 microtesla. This is the magnetic field due to Earth. Horizontal Earth component of Earth's magnetic field. Now let's do the next question. Let's go to the next question. A solenoid of length 8 centimeter has 100 turns in it if radius of coil is 3 centimeter and if it is carrying a current of 2 ampere. Find B magnetic induction or magnetic field at a point 4 centimeter from either end of the axis of the solenoid. And magnetic field formula for a solenoid, which is equals to B, which is equals to mu naught Ni by 2 . Okay, cos theta 1 minus cos theta 2 So when we substitute the values in this equation, B equals 4 pi into 10 power minus 7 into 100 turns into 2 ampere by 2 ampere. We don't need to write here. Into 2 into 4 by 5, which this cos theta 2, I believe we got from the cos theta 2, which is based by hypotenuse or adjacent by hypotenuse. We will get it as 4 by 5 And if we solve this, and I forgot about this one. This is number of turns per unit length. So it should be the length is, they gave the length of solenoid is 8 centimeters. So 8 into 10 power minus 2 here. Finally, we will get it as 800 pi microtesla. The next question. A solenoid has 60 centimeter long, radius which is equals to 4 centimeter, has 3 layers of windings of 300 turns each, a 2 centimeter long wire of mass 2.5 gram lies inside the solenoid near its center, normal to its axis, normal to solenoid's axis. Both are in horizontal plane. The wire is connected through two leads parallel to axis of solenoid to an external battery. Supplies a current of 6 ampere to the wire for what, question is, that is the information, for what value of current in the solenoid the weight of the wire will be supported. Okay, they're saying there is a solenoid which has 3 layers of windings, each is around 300 turns, and there is a small wire having 2 centimeter of length and a mass of 2.5 grams. It is lying inside the solenoid. It is having a 6 ampere current flowing through it. What is the value of current inside the solenoid so that this wire floats in the air or levitates? Now solution: force on wire, which is equals to mg downwards, force which is equal to BIL, which is the force experienced by a conductor. The force experienced by a conductor is BIL or LIB. Here both should be equal, where mg, which is equals to BIL, this current is of wire, the small wire, and length is also of the wire, the force experienced by the conductor. And the magnetic field by solenoid, which is equals to mu naught n into I. This is solenoid current. This is wire, length is also of wire. Okay, magnetic field we have here ILB. This became a triangle. Substitute in this equation here, mg, which is equals to mu naught ni of solenoid is times I of wire times length of wire. And when we want the I of solenoid, so substitute I of S, which we will get it as mg by mu naught ni wire times length. We will get it as mg, which is equals to mass of wire, which is equal mass of the wire, which is equals to 2.5 gram. So 2.5 into 10 power minus 3. They said take g, which is equals to 9.8, but I will take it as 10. Mu naught, which is equals to 4 pi into 10 power minus 7 into number of turns in the solenoid per unit length. So 300 by length of solenoid is 16 to 10 power minus 2, where 6 ones are 6 5s are, and current in the wire, which is equals to 6 ampere times length of the wire, which was 2 centimeter, 2 into 10 power minus 2. So 2 into 10 power minus 2 into 10 power minus 2 cancel. I in the wire, I in the solenoid, which is equal to 2.5 into 10 power minus 3 times 10 power 8 by 4 pi into 5 into 6 into 2. Ones are, twos are. We will get is, which is equals to 10 power 5 by 4 pi. 4 twos are 8, 8 twos are 16, 16 pi times 6 is equals to is, which is equals to 10 power 5 by 96, where is, which is equals to 96 times 3 actually. So I can write it approximately as 10 power 3 by 3. So I'll get I in the solenoid to be around 300 ampere or so. Now let's go to the next question. A, a solenoid of 2 meter long and 3 centimeter diameter has 5 layers of winding of 500 turns per meter length. In each layer, and carries a current of 5 ampere. Find intensity of magnetic field at center. They're asking to find H which is equals to B by mu naught, which is mu naught, which is equals to Ni mu naught by mu naught. Mu naught, mu naught cancel. And we will get N into I, which is 500. Since there are 5 layers of winding, we will get 5 times 500 times 5. This is the number of layers of winding. This is the number of turns per unit length. This is the current. And there seems to be a mistake here. In our previous question here, there should be number of windings should be considered here. Number of windings should be considered. So the final, there should be a 3 below. There are 3 layers here. So the answer should be 3 times 3, so 9. So 300 by 3 is, which is not equal to 300, but 300 by 3, 300 by 3. So is, which is approximately equal to 100 ampere, not 300. Number of windings should be considered. I mean, layers of windings should be considered. So 5 times 500, which will get as 1.25 into 10 power 4. The H, this is magnetic intensity, which unit is ampere per meter. Now that is for that. Let's go to the next kind of questions. Let's go to the next question. A magnetic field of 4 into 10 power minus 3 k cap along the z-axis Tesla exerts a force of 4 I cap plus 3 j cap into 10 power minus 10 Newton on a particle having charge of 10 power minus 9 coulomb and moving in the xy plane. Find velocity of the particle. And since we know that force, which is equals to q v cross b or qeb sine theta, substituting the values, we will get force which is equals to 4 I cap plus 3 j cap 10 power minus 10 Newton is equals to 10 power minus 9 coulomb. This will become 10 power minus 1. So it will be v cross b, v vector cross magnetic field, which is 4 into 10 power minus 3 j cap, I mean k cap, not j cap. So 4 I cap by 3 j cap times 10 power minus 1 is equals to 4 into 10 power minus 3 j cap. And since they said it is acting along the xy plane, so we can write it as vx I cap plus vy j cap cross 4 into 10 power minus 3 j cap, I mean k cap. and comparing coefficients, we can say that 4 into 10 power minus 1 is equals to 4 Vy into 10 power minus 3. So Vy we will get it as 4 cancel, 10 power 2 meter per second. Four I'll be ending the stream and starting it again.